Hello, everybody, and welcome to Backer Breaks It Down. In today's episode, I want to look at something called displacement and density. Okay, so displacement. So, what happens if you add a scoop of ice cream to a glass filled with root beer? The volume of the liquid that overflows equals the volume of the solid below the liquid level. And this volume is called the object's displacement. Okay, so that's just another way that I can find the volume of an object. I can place an object in a container of water or some other liquid. So like Marley, in example 3 here, she wants to find the volume of an irregularly shaped rock. So she puts some water into a rectangular prism with a base that measures 10 by 15 centimeters. When the rock is put into the container, Marley notices that the water level rises 2 centimeters. And this is because the rock is displacing its volume of water. So what is the volume of the rock? Remember, it says the volume of the liquid that overflows, or in this case, rises, right, is equal to the volume of the solid. So what that means is that since the liquid rose 2 centimeters, the volume of the rock I can find by going like area of the base times the height. Well, remember the base is 10 by 15, so that means it has an area of 15 square centimeters. And if I multiply that by the height, the water rose of 2 centimeters, then what I get is that the volume of the rock is 300 cubic centimeters using this idea of displacement. Okay. Now, density. There are a couple of forms of density. In physics, you have density is the mass per unit of volume. Okay. And then you can also, or just like in general, density is the quantity of something per unit measure. Okay. So we'll take a look at some examples of what these various forms of density are describing. Starting with like the most common one, that density is mass divided by volume. And it says the formula is easy to remember if you remember the labeling for density. So if you look at these labels, you've got grams per cubic centimeter, pounds per cubic foot, kilograms per cubic meter. That cubic measurement, that's your volume. Okay, the cubic units are in the volume, so that's why they're going on the bottom. So that's just another way of like remembering this particular rule for density, mass divided by volume. In this example here, it says the density of a fish tank is 0.5 fish per cubic foot. If the volume of the tank is 12 cubic feet, how many fish are in the tank? Okay, so I know that my density is 0.5 fish per cubic foot. And density is found by going mass divided by volume or like some quantity divided by volume. Now I know my volume is 12 cubic feet, so it makes sense for me to put it on the bottom because that's where the cubic feet are. And then on top, this would be representing the number of fish. Okay, so to kind of write it a little bit more in a condensed way, we'd have 0.5 is equal to x divided by 12. And if I go and multiply both sides of this equation by 12, that will tell me how many fish are in the tank. So 12 times 0.5 is 6 fish. So here we weren't necessarily working with mass, which is why, like it even said up here, density is the quantity of something per unit measure. So in this problem here, that quantity was fish, and then it was like per like cubic units. And the cubic units, the volume is that unit measure that they're speaking of. This is the problem in your notes packet, okay? So here we have a clump of metal. All right, I'm gonna get my highlighter out. A clump of metal weighing 351.4 grams is dropped into a cylindrical container, causing the water level to rise 1.1 centimeters. The radius of the base of the container is 3 centimeters. What is the density of the metal? And then using that, we want to identify what kind of metal it is. So density is mass divided by volume. And so I know the mass of this metal is 351.4 grams. I need to find the volume. Now they told me it was a cylindrical container, and volume of a cylinder is pi r squared times h. Now in this problem, they dropped the metal into a container of water, and the water level rose 1.1 centimeters. So that's like what we're going to use for h. And then of course they gave us the radius is 3. So when it comes to the volume, I'm looking at pi times 3 squared times 1.1. So let me calculate this. And I get approximately like 31.1. And that would be cubic centimeters. All right. For me to find the density, I need to take the mass and I need to divide it by the volume. So I'm going to do that here. And I'm going to have 351.4 divided by the 31.1. So 351.4 divided by 31.1. And I'm getting like 11.3 for the density. So 11.3 grams per cubic centimeter corresponds to the lead density in the table. So that would be the metal. So density, all right. So one of the descriptions of density was that it's the quantity of something per unit measure. So that unit measure could be volume, it could be area. Population density problems are common, like especially when it comes to those like standards assessments. Okay, but population density fits this definition of density because it's the measure of a population divided by the total area. Okay, for people, population density is the number of people per unit of area, like square miles or square kilometers. To solve these problems, look to the final label, people per square mile, which can be written people over square mile and is obtained by dividing the number of people and the number of square miles. Okay. So the population density of Giantville is 16 giants per acre. So there you have like that final label, like people per square mile. We have 16 giants per acre, and that's the population density. Exactly 800 giants live in Giantville. How many acres is in Giantville? So kind of like creating a proportion of sorts. Like if they tell me there are 800 giants there, well, that would go on top. The unknown number of acres is on the bottom. Okay. So to write this a little bit more simple, I'd have 16 is equal to 800 divided by A, the number of acres. And so then doing the math here, I would get 50. So 50 acres is in Giantville. Okay. And then there's something called quantity density. It says density questions need not only deal with living organisms. For example, the size air conditioner that is purchased for a room depends upon the volume of air space being cooled, or BTUs per cubic unit of space. They just say, again, to solve these problems, look to the final label BTUs per cubic foot of airspace, because that will basically tell you how to set up your problem. Okay, so those are like the various forms of density. You have the standard one in physics. Density is mass divided by volume, or you can think about it more generally. Density is the quantity of something per unit measure. So quantity per area, quantity per volume, and that quantity could be mass. Okay. And that's how Backer breaks it down. Have a nice day.